Welcome children. We have gone through various trigonometric equations. Today we will explore trigonometric equations. Okay. See the first one. It says if sine x is 0, then the possible angles x can be is n pi. This is the general expression for x. If the equation is sine x is equal to 0. That means we are exploring various values or various possible angles that x can be. We can quickly see how x can be n pi in case sine x is equal to 0. So we will quickly think of various angles at which sine function becomes 0. You all know that sine will become 0 at 0 degree or at 0 radian. So if the angle is 0, sine will become 0. And if we take a leap of 180 degree or pi radians, then also sine of that becomes 0. Then you go by 180 degree further, the angle comes out to be twice of pi, that is 360 degree. It coincides with 0. So again it is sine of 2 pi is 0. Then again when your angle coincides with pi, the angle becomes thrice of pi. Okay, by 180 degree each angle is increasing. So 0, then 1 pi, then we get 2 pi, then it is 3 pi. Then you will see 4 pi also coincides with 0 or 2 pi. So you will find every time the angle is coinciding with either this part of the positive x-axis or this part of the negative x-axis, whatever angles are along them, sine of that angle is becoming 0. So we quickly have a look at these angles. If you see, they are all defining, or they are all the multiples of pi, all multiples of pi. So this is 0 into pi, then 1 pi, 2 pi, 3 pi, 4 pi, and so on. So we can generalize these angles. We can say whenever x is of the form n pi, sin x will be 0. You can substitute the values for n and check. If n will be 0, x will become 0. If n will be 1, x will become pi, and so on. Understood? So sin x is 0 will imply x is equal to n pi. In the same way, for tan x is equal to 0, x will be n pi, because wherever or for whichever angle sin x is 0, tan x will also be 0, because tan x is sin x over cos x. Now coming to the second part, now we have to check for which all angles cosine will become 0. You will find cos at 90 degree or at pi by 2 radians is 0, and it is also 0 at 3 pi by 2 radians. So every time your angle will coincide with pi by 2 or it will coincide with 3 pi by 2, cosine of that angle will become 0. So see, after 3 pi by 2, if we go ahead by 180 degree or pi radians, the angle will become pi by 2 plus pi. Okay, that on solving comes out to be 5 pi by 2. So for that also cos becomes 0. Then go further 180 degree ahead, the angle will become 3 pi by it will become 5 pi by 2 plus pi by 2. You will see 5 pi by 2 plus pi, you can see by 180 degree we are going, so the angle reduces to 7 pi by 2. In this you again add 180 degree or pi radians, you will see the angle is 9 pi by 2, and so on. This will be then 11 pi by 2. So what do we wonder? We see that all these angles are multiples of pi by 2. And what is their nature? They are all odd. This is 1, then it is 3, then 5, 7, 9, 11, and so on. So cosine of x is becoming 0 when x is an odd multiple of pi by 2. So this is an odd multiple of pi by 2. 2n is always even. N multiplying with 2 will always give us an even number, and when 1 is added to it, obviously it will become odd. So if cos x is 0, then the general formula for this x will be, general values for x will be 2n plus 1 whole multiplied with pi by 2. Everywhere here n is representing an integer. Okay. Now coming to the next one, for any real number x and y, if the equation is of the form sin x is equal to sin y, then x will be n pi plus minus 1 to the power n into y, it will be here, for all n belonging to z. So we are going to prove it now. See, this equation sin x is equal to sin y can be written as sin x minus sin y is equal to 0. And we can simplify it. We know the formula for sin a minus sin b. So using that, it can be written as 2 cos x plus y by 2 into sin x minus y by 2. So this will be equal to 0. Now if this product is 0, that means either cos x plus y by 2 is 0, or the second condition will be sin x minus y by 2 is 0. So we are going to explore these two conditions and see what will be the relation between x and y. Okay, look at equation 2. Whenever cosine of certain angle is 0, that angle can be written as odd multiple of pi by 2. So you can see cos of this angle is 0. That means this angle can be written as odd multiple of pi by 2. So if you see here 2 on both the sides, we can cancel out, and then we can shift y to the right hand side, and we get x is equal to 2n plus 1 into pi minus y. So this is giving us one set of possible values of x. Okay, let us explore the next one. If sine x minus y by 2 is 0, we know sine of certain angle is 0. That means that angle must be n pi. Okay, now solving this part on cross multiplying 2 and shifting y to the right side, we get x is equal to 2n pi plus y. So this is the second one. Now compile both of them, first and second, go through them and see what all angles x can be. This says if x is odd multiple of pi, then y is getting subtracted from it. And the second condition states when x is even multiple of pi, y is getting added to it. So we are getting all the multiples of pi. This is denoting even multiple of pi. This is denoting odd multiple of pi. But the only difference is whenever x is represented as odd multiple of pi, y gets subtracted from it. And whenever it is represented as even multiple of pi, y is getting added to it. So keeping this in mind, we will write a general result from 1 and 2. X can be all the multiples of pi, because see, we are getting odd as well as even multiples of pi. So in general, I am writing it as n. But we need to ensure whenever n is odd, y is getting subtracted from it, and whenever n is even, y is getting added to this. Okay, so how do we ensure it? So we write x as n pi plus minus 1 to the power n times y. So you look at this part carefully and see if the requirement is fulfilled or not. Let us verify. Okay, see, suppose n is 1, so it will be odd. Okay, so this becomes only pi. And what about this part? Minus 1 to the power 1 will be minus only. So that makes it minus y. So you make n 3, it will become 3 pi, and minus 1 to the power 3 is also negative. So we again get minus y here. So every time n is becoming odd, this one becomes negative and we get minus pi. In case n is even, suppose n is 2, then this will be 2 pi, and minus 1 to the power an even number will be always positive, and we get plus y. So if you have an equation of the type sin x is equal to sin y, you can write the general value for x, that will be n pi plus minus 1 to the power n into y. Okay children, now in the same way, let us find the general formula for solving equations cos x is equal to cos y and tan x is equal to tan y. Quickly doing for cos x is equal to cos y. See, this can also be written as cos x minus cos y is equal to 0. That will imply minus 2 sine x plus y by 2 and then sine x minus y by 2. So considering both the conditions, either this function is 0 or this one is 0. One by one, let us check them. So either sine x plus y by 2 is 0. And we know if sine of certain angle is 0, that means that angle must be a multiple of pi. So we can write x plus y by 2 is equal to n pi. This means x can be written as 2n pi plus y. So this is the first set of possible values for x. Sorry, this has to be minus because we have x plus y by 2 is equal to n pi. So this will be minus y. Now taking the second condition, that is sine x minus y by 2 is 0. This will imply x minus y by 2 has to be n pi. Okay, if x minus y by 2 is n pi, that means we can write x is equal to 2n pi plus y. You can go for using some other notation over here. If repeatedly n is being used, we can use m here. Okay, otherwise you can proceed like this as well. So now compare 1 and 2. What do you find? In the first case, we are getting x is an even multiple of pi and y is getting subtracted from it. In the other case, we are getting x as even multiple of pi again, but y is getting added. So what does it implies? No matter whether, though in both the cases you can see x is an even multiple of pi. We don't have odd multiples of pi. So obviously x has to be 2n pi, but it may be in one of the even multiple of pi, y is getting subtracted, in the other one it is getting added. So both cases are possible. So we are going to take it as x is equal to 2n pi plus minus y. Okay, I will quickly explain you through diagram how it is possible. Okay, see, if the angle is 2 pi plus, we get angles of the first quadrant. If it is 2 pi minus, we get angles of the fourth quadrant. And in both of them, cosine is positive, that you are aware of. So in both the cases, if I give you an example, say cos theta is 1 by 2. Fine. Now this 1 by 2 can be written as cos theta is equal to cos 60 degree. Got it, children? So your x here is replaced by theta and y is replaced by pi by 6. Sorry, this is pi by 3. 60 degree it is. So we'll make it pi by 3. So y is pi by 3. Okay. Now apply this result. If we use this result, theta has to be 2n pi plus minus pi by 3. So you can see cos theta I have taken positive and theta is coming out to be 2n pi plus minus pi by 3. So go for any one single value of n, because we are saying n is an integer. Let us go for n is equal to 0. If n becomes 0, this entire part will become 0. Okay, then what is theta? It is plus pi by 3, it is minus pi by 3. Let me draw a line here and say this angle is pi by 3. Okay, in that case, what will be the angle minus pi by 3? It will be here. Okay, and what do we know? Cos minus pi by 3 is cos theta only. So both the cases are possible. You can check for another value of n. If n is 1, this will become 2 pi plus pi by 3. So 2 pi plus pi by 3 means again coinciding with the angle pi by 3. And 2 pi minus pi by 3 means again coinciding with this angle only. So in both cases, fine, the conditions are fulfilled. So the possible values for x can be 2n pi plus y minus y both for n belonging to integers. Now quickly taking one last one. If tan x is equal to tan y. Okay, we'll simplify it fast. Tan x can be written as sin x over cos x. Tan y can be sin y over cos y. If we cross multiply both the sides, we get sin x cos y is equal to cos x sin y. Okay, and shifting this to the left side, our equation reduces to sin x cos y minus cos y, sorry, this is cos x here, and then sin y. Recall what formula it can be converted into. If you look at this carefully, it is of the form sin A cos B minus cos A sin B. So you can recall the formula for sin A minus B. So this becomes sin x minus y is equal to 0. See, again we are facing the situation sin x is equal to 0. And if sin x is 0, okay, sine of certain angle is 0, that means that angle can be written as a multiple of pi. That means x reduces to what? It is n pi plus y. So children, you can see that for a particular trigonometric equation, general results can be obtained. We can find for what all values of x the given condition can be satisfied. So these are all general solutions if you see. Okay, let us see what particular solutions are. When we talk about particular solutions, it means we are talking for particular values of n. Okay, so we need to see what those particular values are. Okay, now if your angle is greater than equal to 0 or less than equal to 2 pi. Can you see children, we are only covering all the angles which are obtained while completing one revolution. We are covering only those angles. Okay, we are not going beyond that because if the angle becomes larger than 2 pi, it will be coinciding with one of these angles only. So if n is such that your angle x is an angle from 0 to 2 pi, then x is principal solution. So for those values of n where x becomes an angle of this range or this particular interval, then x will be termed as a principal solution. And when we write it like this, it will be general solution. These are all general solutions. We can mention here we are doing general solutions of trigonometric equations. Okay children, so that is what about the class today. Go through them carefully and then we will be able to take their questions which are based on them. Okay, so we can mention here we are doing general solutions. These are all general solutions.